Here's Pre-Calc. It's part 2 of 6.1.1 lecture video. We're learning how to derive the law of sines. There's one for an acute triangle and one for an obtuse. I'll just do the acute triangle. So I'm just looking in your book right here. So it says, in the figure at right, A, B, and C denote the sides opposite angles A, B, and C respectively. Use the diagram to complete the following problems given that triangle ABC is an acute triangle. So I've written down all the little, everything that we need to be able to see. It says express H in terms of angle A and side length B. In terms of angle A and side length B. So what they want us to do is to use our SOHCAHTOAs. So angle A, side length B, we're talking about this triangle right here. And so if this is the angle, this is opposite and this is hypotenuse. So I could say something like sine of A equals opposite, which is H, over hypotenuse, which is B. And then I can solve that. I'll get this closer. Let's see. I can solve that for B by just multiplying both sides. Well, it's like cross products. So H. Oh, I need H by itself, right? So I just need to multiply both sides by B. So H is equal to B times sine of big A. Big A is the angle. Okay, I think we're so far so good. Okay, letter B says, write an equation to express H in terms of angle B. Now we're talking about angle B and side length A. So they want me to kind of use my SOHCAHTOAs on this triangle over here. So I think we can do this. B. So this is still opposite and hypotenuse. So sine of B equals opposite, which is H, over hypotenuse, which is A. But they want H, they want me to, solve it for H. So I'm going to multiply both sides by A, and then I would have H equals A times sine B. I know, they're just leading us through it right now, and it might make sense later, I hope. Use the results from part A and B to show that sine A over A equals sine B over B. Well, I see that both of these things are equal to H. So my idea was to kind of use equal values and just take this one, B times sine of A, and set it equal to this one, which is A times sine of B. But I want it in this form. So I think I know this is kind of weird, but I think I need to divide both sides by AB, because you know how you can do something as long as you do it to both sides? Because then that's going to help me, see how there's no A's and B's up here? It's going to help me cancel them out. And so in this one, the B's cancel out, and then I just get sine of big A over A, and here the A's cancel out, so I get sine of B. So they're just talking us through this. And then letter D says, if you drew an altitude to side BC instead, or side BC, I'm going to have to draw an altitude to side BC, and followed the same method, what would the result be? Altitude to side BC. So the only altitude I could possibly draw to side BC would be from here. Try to make it look like it's a right angle. I know that doesn't look exactly like a right angle. And if I did the whole darn thing all over again, then I could say, and I called this piece, I guess I can call this H. Is that a H? It's upside down. I could say sine of B is opposite, well here, let's see. Sine of B, opposite, we're just going to call it H, opposite over hypotenuse O. Okay, so that's going to be C. So that means H would be, if I multiply both sides by C, C sine B. And oh, is that all I have to do? Combine the results from, well, first let's check this. No, I think I need to finish it like how we did it. We did it twice. We did it here, and then we did it here. So the first time we did it, we expressed in terms of A and then B. So in here, if we're drawing this altitude, we're going to express it in terms of B and then in terms of C. So I think I have to do it one more time for sorry, you can't see. One more time for in terms of C. That's a, can't see it. Here, let me back up some. There we go. Okay, so I drew this new altitude and I called this new altitude H. It's kind of upside down, sideways H. And I used it in a SOHCAHTOA concerning angle B. Now I'm going to do it again with angle C with this little triangle over here. So I'm going to say sine of C is opposite over hypotenuse. All right, I can do that. Sine of C equals opposite. What was opposite again? H over hypotenuse, which is little b. And then I'm going to express H in terms of the rest of it. So I'm going to multiply both sides by B. And that gives me H is equal to B sine C. And then, so I'm kind of doing a repeat of all this stuff that we already did. So now I have H is equal to this thing and H is also equal to this thing. Therefore, these two things must be equal to each other. So I'm going to say C sine B is equal to B sine C. And then the procedure that I used up here was to divide both sides. Like here I divided both sides by AB. Here I'm going to divide both sides by BC. And that's just so that I can get it into that form. They're asking me to get it into a certain form, and so I know I can divide both sides by anything I want. This is the thing I want to divide by, though, because then I can get sine B over B equals sine C over C. So now, just like I had sine A over A equals sine B over B, now I've got sine B over B equals sine C over C. So basically, these things are all, if sine A over A, if that's equal to sine B over B, but sine C over C is also equal to the same darn thing, they must be equal to each other. See, because these two are the same. So these are both equal to the same darn thing. So that means they're equal to each other. And so this last part says, combine the results from part C and D into an extended proportion to show the law of sines. And we already know, I think we already know the law of sines. The law of sines is sine A over A equals sine B over B equals sine C over C. So, and I can easily justify that now. So I'm going to say sine A over A equals sine B over B. But didn't we say that sine B over B equals sine C over C? So I can just, you know, it's like by substitution or whatever. And that's the law of sines. And that's just a little derivation of the law of sines. And I think we're going to be doing more with that later, but that'll get you going for the lesson.